So the spar moron has made another video. And it's just more garbage. The way he did the rubber band, it's idiotic. So he says, look, I had to stretch the rubber band because if I didn't stretch the rubber band, there'd be two rubber bands. So what's wrong with two rubber bands? How
I will now leave the rubber band like this. I will not stretch this one, but leave it like this. Check.
all of the how crappy it is in terms of the way he's configured the weights. Gluing shit rubber bands holding the weights on. That means the weights can shift and move based on how much tension's in the rubber band.
All the objects are not tied together with rubber bands this time. They are all taped together, all stuck together. So yeah, there you go.
I mean, just all kinds of bullshit. Little bent nails.
I have replaced the long crooked nails with straight short ones. There you go.
Ridiculously flawed and garbage experiment. And I won't even talk about the measuring bullshit, right? The same bullshit. He draws a curved line on the background and we're supposed to believe that somehow he's gotten this curve correct.
Let's double check the velocities with the timer. So the bottom of the carbon rod is going through the photo gates. As you see, as I'm moving it through the photo gate, through the timer, you can see the numbers over here. So let me first drop it from 2 velocity. Hold on, let me pick my other hand. Yep, right, that gave us 15. Hold on, let's do another try. Alright, that gave us 14. Another try. That gave us 15. Once more. 16. 15. Alright, so you can see a pattern between 14 and 16. Alright, now drop from the 1 velocity mark. $28, $29, $30, $30, $30 again, $30 again. So I think that's pretty clear. 31, that this is pretty much half the velocity. Okay, so these are pretty much exactly, this one goes twice as fast as this one.
He pushes the weights up to a nail, which doesn't guarantee the center of mass is the same for these big giant things versus the little tiny things.
Okay, so the form mass is suspended. This is the baseline, and you can see how the middle of the battery is aligned with the baseline. So the center of mass is aligned with the baseline. Now I'm going to move it upwards, and you can see how, well, hold on, right, it's still the middle of the battery, still the middle. Now we're approaching the 1 velocity mark. All right, so you can still see that the middle of the battery is aligned with the 1 velocity mark. So the center of mass is aligned with the 1 velocity mark. All right, now continuing to moving it upwards. Hold on. Really difficult to record it. So still the middle. All right, still the middle. Now this is the 2 velocity mark. Over here. You can see still the middle of the battery is now at the 2 velocity mark. All right. Center of the mass is aligned with the 2 positions, the two velocity positions, the 2 velocity and the 1 velocity. Should I show it again? It's aligned. The center of mass, the middle of this mass object is aligned with this curve with the 1 velocity mark and with the 2 velocity mark. Can it be more clearer than this? I have hammered the nail over here, so now when I place it over here, the center of mass is aligned with the 1 velocity mark. So where's the center of mass? Well, it's in the middle of this circle. The middle of the battery and in the middle of this circle. You can see when I show you from above that it is in the middle of the circle. Okay, it's aligned with the middle of the circle and it's aligned with the middle of the battery like this. So I did my utter best to make sure that it is aligned with the center of this object. Once more. So this is the 1 mass at the 2 velocity mark. You can see that the middle to the center of the circle is aligned with the 2 velocity mark, and it's quite perfect. Okay, you can see that, right? Right. About the ruler, since the rubber band is hanging quite low, I cannot place the ruler like this anymore, because as you can see, the rubber band is colliding into it. So I will have to place it like this, but when then viewed from the side, you wouldn't be able to see the markings. So I had to manually put the markings on them. So as you can see, I've done this with pencil on the side of the ruler. So problem solved in that way. Here is my new 4 mass object, which consists of like three of these round objects, and on each side I have a battery taped. The carbon rod goes through the middle round thing, so it's really at the center, and the bottom of the carbon tube is sticking out, so this part will be pushing against the rubber band. So the batteries are also at the centers. You can see it's aligned with the carbon rod, this side as well. So now, oh yeah, well, not perfectly so I gotta like adjust it a little bit. But now, where is the center of mass? Well, it should be perfectly in the middle. Perfectly in the middle. So now I'm going to suspend it again, and you will see that the center of mass will follow this line once again. The 2 mass object, it's the same principle. There is one round object now and a battery on this side and a battery on that side. So once again, the battery is aligned with the carbon rod, so it's at the middle of the round of the circle. The other side the same. Well, it seems like I have to pull this one a little bit like this. And then we have the same effect. It's in the middle of the circle. So where is the center of mass? Well, in the center, in the middle of the battery, and in the middle of the circle. So same principle. Then we have just the 1 mass object left. Come on, focus. Right, this is it. So the carbon rod goes right through the middle. So where is the center of mass? Perfectly in the middle. Like right here, I suppose. Okay. If this is good enough. I don't know. Whatever, you don't accept any goddamn thing. This is the 4 mass 173.85 grams. This is a 3 mass 130.30 grams. This is the 2 mass 87 grams. This is the 1 mass 43.35 grams. Now the 1 mass going 1 velocity. It's 1, 2, 3, 4. Okay, now the one mass going 2 velocities. Press record. Let's see. Okay, there we go. It's 1, 2, 3, 4. Right. Okay, so now the 2 mass released from the 1 velocity mark. Let's see. Okay. 1. Do it again. 2. It was not really straight. 3. All right, once more to be sure. All right, that should be enough. I gotta stop this recording. Velocity. See. Okay, there we go. So let's try out the 4 mass. Okay. That's 1, 2, 3, 4. Right. Should be enough. Here I have all the results written down. Let's check it out. So I have a 1 mass going 1 velocity, and that produced stretch distance of 2.2 centimeters. Then I have the same 1 mass going twice the speed, 2 velocity. That produced a stretch of 4.35 on average, 4.35 centimeters. Ideally, it should have been 4.4, so it's still very close, 4.35. Then I have a 2 mass going 1 velocity, it produced a stretch of 3.1 centimeters. Then I have the two mass going twice the speed. That produced a stretch between 6 and 6.1 centimeters. Ideally, it should have been around 6.2 centimeters. So yeah, still pretty close. Then we have a three mass going one velocity. That produced a stretch of 3.85 centimeters. And then we have a four mass going one velocity, and that produced an average stretch of 4.4 centimeters. So what do we see? The one mass going twice as fast has pretty much exactly the same stretch as the four mass going one velocity. This one went for 4.35, this one went 4.4. So yes, 0.05 centimeters, like a half a millimeter in difference. It's a very small difference. Very small difference. Okay. So for in the theory, the predictions, so John Walker gave me the equations, or he showed me the equations, in order to, so we know the stretch distance of the one mass going one velocity. In order to calculate how much a two mass going one velocity should produce, and how much a three mass going one velocity should produce, and how much a four mass going one velocity should produce in theory, we simply have to do 2.2, so this one, times the square root of 2. And that equals 3.1. And so indeed, the two mass going one velocity gave us a stretch distance of 3.1. So that's a perfect result. The theory matches the practical results. Then for the three mass going one velocity, we have to do 2.2 times the square root of 3. That equals 3.8. And we have three mass going one velocity, a result of 3.85 centimeters. So 3.8, 3.85, very close result, a very similar, very small difference. So the theory and the evidence, the practical evidence are in line, they match. Then for the four mass going one velocity, we have to do 2.2 times the square root of 4. That equals 4.4. And that's exactly what happened. The four mass going one velocity went 4.4 centimeters, had a stretch of 4.4 centimeters. So the theory and the practical results are perfectly in line with each other for conventional science. For draft science model, on the other hand, he claims momentum is energy, so the one mass going two velocity should create exactly the same stretch or produce exactly the same energy as a two mass going one velocity. Of course, that didn't happen once again. We have a 4.35 and 3.1. The ratio and difference, if you divide this one, 4.35 divided by 3.1, or ideally 4.4 divided by 3.1, we have 1.4. We have a difference ratio of 1.4. So yeah, draft science, you are wrong again. The more I try to improve it, the more the more you point out the flaws and the more I improve it, the better results become in favor of conventional science. So thank you, actually. Oh yeah, and you keep calling me a moron. Well, you have been a moron since the beginning, since the very beginning. Yeah, you have been claiming that momentum is energy. Go ahead, call it a crap experiment again. Absolute garbage experiment.
And that's all they have. They have no physical evidence of this crap. And then they contrive these sloppy, dirty, stinking, lazy, bullshit experiments and claim they're proving that's the truth. You're such crude, moronic pieces of garbage. You're defending something this fucking stupid when they can't even show an experiment demonstrating that 4 pounds dropped 1 foot is the same energy as 1 pound dropped 4 feet. And the only way they can show that to be true is to cheat the hell out of it. To just plain cheat. God, I hate this planet.